So here we go. So we're going to try and walk through a little bit of some calc with stuff. I'm starting with a very basic sine guy. Some of you saw what I just put on the board. This is a really good one to look at. Okay, I can talk through this one at lunch. But if I want to know what this guy looks like, your comfort might be y equals sine x first. And I can look and go, okay, y equals sine x is that, and I know stuff. That's at 0, 0. This to you guys should be at we'll do radians. Pi over 2 comma 1. This is pi comma 0. This is 3 pi over 2 comma negative 1. And this is 2 pi comma 0. Okay. These are positive moments. These are negative moments. And from that, I hope I could translate that and saying, okay, I'm going to look at my blue guys first. And it starts with no radius, and then it seems to get bigger, 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 bigger to there. This one is a clean one. This is a very nice one. It's at 1 pi over 2. Now this is in polar world. 1 meaning radius of 1, angle 90 degrees. That here, if I like focused it for you, that's that moment. Then it seems to decrease back down to 0. So it looks like I created a circle. And what happens after that? It retraces it backwards. I should be in the third and fourth quadrant, but it's all backwards. And if I focus on one specific color here, we need here. That moment there is this one where I'm looking due south with a radius of what? Negative 1. And I know that's our go-to. How high up is that yellow? 1. But what's his radius worth? Negative 1, because he should be down low. So I'm trying to show it to you visually. What's the other way you did as a warm-up? You did this one in a warm-up. And could you also try and go r times r equals r sine theta, x squared plus y squared equals y, x squared plus y squared minus y plus blank equals blank. Half of negative 1 squared is 1 and a 1, and now I got it as x squared plus y minus 1 squared equals 1. Is that the same thing rectangularly? So you can convert it by hand with the algebra manipulations. Can you try to convert it visually with my new trick that I've been doing with Desmos and my blues and reds on paper? Somehow you got to learn stuff. Which way works best for you? Hit me. Ooh, Parker asked if I took the absolute value of this. So he's saying if you did the absolute value of that, it would, this is my guess real quick, thinking out loud, it should look like that in the world of rectangular. Good. Which means in the world of polar, my negative radiuses, you just forced all the reds to flop to blues. So I bet it would look like that. Okay? That's a great idea. Did you hear him? To me, it's like a Swiss Army knife almost, or like a bike wrench where you can flip the thing open or closed. All the negative radiuses, if you absolute value them, it doesn't change the value. It just changes the sign. So the reds go to blues, which I think you make the like infinity sign or the number 8. Okay, so here's my question that I want to look at is how easy is it to get dr d theta if we started in r's and thetas? So dr d theta would equal what? Cosine theta. You guys good with that? It's easy. And that here, if I drew that, would look like this. You guys okay with that? I'm drawing your blue. What do you think it means if it's positive? Like, here's this section that's positive right here. That's the positive section. What do you think that means to your chomper? If your chomper's dr d theta is positive, the radius is, does it mean the radius is positive or the radius is growing? Yeah, so dr d theta, if it's positive, look what happened to these guys. Small radius got bigger, got bigger, got bigger, got bigger, got bigger, got bigger. Do you guys see that? Now look what happens here. Now my radiuses are negative, or sorry, now my dr d thetas are what? Negative. So what happened to my radiuses? They decreased. So it's not about the slope of the tangent line at all. It's about the radius and how the radius is growing or shrinking. So it's the chomper's chain, how it's growing or shrinking. Good with that? Now, 2 comments. dy dx. If I want dy dx, I know I got 2 minutes left. Not dr d theta, if I want dy dx. Okay, think of it this way. If r equals sine theta, what did we say at the very beginning of class that x and y are? If I have x equals who? R cosine theta. Y equals r sine theta. And do I know who r is? So tell me now, who does x equal? Sine theta, cosine theta. Who's y equal? Sine theta, sine theta. Do you see how I just replaced the function for your r? Do you think you can figure out if I want dy dx then? This should feel like parametric now to you. Remember the last couple days, can theta be t or could t be theta? Could I say dy dx is dy d theta over dx d theta? Good with that? Which is going to be, let's see, this derivative, take derivative, over, take this derivative. Good with that? Okay, and I did the math there. What are some questions I can answer or ask if I know dy dx? Just like we did in parametric, what could I ask you? When am I horizontal? When am I vertical? When am I horizontal? When who's 0? When the top or bottom? When am I horizontal? When am I horizontal? When the top is 0. When am I vertical? When the bottom is 0. So I did the work there. Now, this is the beauty of a video. My video made me slow down a little bit. Why don't you guys just go? But I'm going to record about 4 more minutes. Can you just watch those 3 or 4 more minutes tonight? So you don't need to watch video 1 or video 2 or any of video 3 except for like the last 4 or 5 minutes, okay? I just went 5 minutes slower because of all the video processing. Bye, guys. Whew. All right, so here, you're going to hear this sometimes where it says find when the tangent line goes through the pole. And that's really saying when does the angle, what angle do you use to go through the origin? So if I graph 2 cosine 3 theta, what you're going to learn on Desmos or in your polar petal discovery is it has 3 petals. The first petal starts on the far right. And as you loop through those petals or those loops, it goes through the origin a couple times. So if I show you the yellow dot here, yellow dot starts here and it's going to go up and back down, and right there I want to know when it went through the origin, and that's the purple angle. Now it's going to trace into the 3rd quadrant, but it's really the 1st quadrant negative until it loops out at the red angle. That's the red exit. It's almost like an exit ramp. Ooh, think of like mouse traps on I-25 and I-70 when you're trying to get off I-25 and get on I-70 or get on E-470. That's a crazy intersection loop. I'm asking you at what angle do you exit the loop or exit the on-ramp or off-ramp. Then it goes through the next pedal and it exits, or you can say enters, through the blue angle until it gets back to the beginning. Now the question is, did that get back to the beginning at 360 degrees, or did it only do it at 180 degrees, and maybe I have to re-loop it? Okay, so first comment is, if you want to see this, you might appreciate trying to draw in rectangular first. So rectangular is y equals 2 cosine 3x. So I know I go up 2, down 2. I know I start up top. I know it's going to do the down and up part, but I'm curious about the period. So the period is 2 pi over 3, which, if you want to live in the world of degrees, that is 120 degrees. So you might like me showing you 120, 240, 360, and the graph's going to look like this. Repeat, repeat, repeat. I can also show you blues, reds, blues, reds, and it repeats like that. And the whole thing from my morphing Desmos app or from my other Desmos app is watching the blues and reds. You really need to understand that here comes some blues, here comes some reds, here comes some blues, here comes some reds, and the red continues until it hits a blue again. Then the blue flips to a red, and then it comes back out as a blue. Now, if you kind of watched how many blues and reds I drew up here, I mimicked that same amount of blues and reds down here. You need to become your own Desmos file, so you go blue, red, 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 blue, red. And back to the original question, it says, at what angles do I go through the origin? All I'm asking for is these moments right here and here and here and here and here and here. I want to know when I go through the axis if you think rectangular, or when I go through the origin if I think polar. Luckily the math is you set equal to 0 and solve. It's like finding roots. It's like finding roots. And maybe there's some good metaphor I can talk about with the rose petals and roses and flowers and the roots of the flowers. I'll work on that later. All I do is I set the radius equal to 0, or up here you can set y equal to 0. Set it equal, you know your unit circle. 3 theta equals pi over 2, 3 pi over 2, 5 pi over 2. Divide by 3, you get pi over 6.